Yeah, Aisha.
Yes, ma'am.
All right. See, we have to start with the fresh chapter, that is vectors. Now, before you know what are vectors, you should know how the physical quantities are divided. So, see, physical quantities are grouped into two categories. One of the quantities is known as vectors. Other group is known as scalars. So you have vectors and scalars. So understand what's the difference between them. Then we'll focus solely on this chapter, that is vectors. See, when you have the term vectors and scalars, both of them have magnitude. Vectors also have a magnitude and the scalars also have a magnitude. Now, having a magnitude means the number without the signs. Like if I say minus 5 meter per second is the velocity. So what's the magnitude? Just 5. How high is it? That will just tell us the numerical value. Only the numerical value, ignoring the signs, is what is meant by magnitude. Like if I tell you the force is minus 8 Newton. So magnitude will be 8, not minus 8. If I say, let's say, acceleration is plus 4 meter per second square. So magnitude will be only 4. Okay. So for all the numbers without the sign are the magnitude. So vectors will also have the magnitude. Scalars will also have the magnitude. So what's the difference then if both of them have the magnitude? Vectors are direction specific. They are direction specific. Means all the quantities that will come under vectors, they'll be direction associated. They will have a particular direction towards left, towards right, up, down, towards north, towards east. Like this, direction will be specified. For scalars, there are no directions. No directions are present for scalars. Then one more difference is there. They obey the vector laws. Vectors obey the vector laws. Vector laws are obeyed by the vectors. Okay, these are certain laws we'll study. Parallelogram law is there, triangle law is there, polygon law is there. So these laws are there that we'll be studying slowly and slowly, not in today's class. Those vector laws are needed to solve vectors. In vectors, anything can be there. I took a class yesterday where we were getting 2 plus 1 as root 7. So when you know 2 plus 1 is 3, your 2 plus 1 can be 0, it can be minus 5, it can be root 3, anything. So for solving that, you require the vector laws because they are not solved normally using algebra. But scalars can be solved using algebraic laws. So here you use algebraic laws. Algebraic laws mean your addition, subtraction, multiplication, division. Then comes the examples. We have discussed example given are, you can take various examples which we have studied in the previous chapter. This is a part of motion in a plane, chapter 3. Vectors are a part of that. Okay, motion in a straight line is over. So force, we studied velocity, we have studied acceleration, we have studied displacement. All these are vectors. And here we have the example. You can take speed, you can take mass, you can take distance. All these are scalar quantities which do not have any direction. They don't have direction. Energy, all these are scalar quantities. So slowly you'll understand more about vectors. I'll start with the vectors right now only after this. First write it till here, then we'll discuss more.
Okay. Done, ma'am.
All right. Let's come to vectors. See, how do you represent a vectors? How are vectors represented? You will always find an arrow on the top of any vector like this. A vector is represented by an arrow on its head. Sometimes you can find the letter is written in bold like this. That also means that this is a vector. So most of the books have this arrow only, but just in case if you see any symbol bold, it means it is representing vectors. See, how do you have anything made? What is F? F is the force, that is the physical quantity. Equal to sign 2. 2, this 2 is what? It's the magnitude. Newton, it's the SI unit. And due east is the direction. See how complete a vector is now looking. This is how the vector looks like. These are the various components of the vectors. How are they situated? So remember, for vectors, this is the symbol that you use on the top of every vector. This term is This term means the back of the vector, this symbol. This is called as the tail of the vector. And this symbol on the top of it, this is called as the head of the vector. This is what is required. So when you have any vectors, you are going to use all these things. Even if I put a negative sign here, that shows the direction. Right now, I don't need to put negative because direction is written properly. So vectors are made up of magnitude, direction, and the vector laws. Okay, is it clear till here?
Yes, ma'am.
Okay, let's study few types of vectors and you can write down all these things together. Two vectors whose magnitude is same. Okay, magnitude is same and direction is also same. They are called as equal vectors. I'll write like, see here. If I say one vector is here, 3 Newton. F2 is there, 3 Newton. Can you see here? We have the same magnitude. Both have the magnitude. How much? 3. Yes, 3 is the magnitude. And their direction is also same towards the right. So, same direction. We have negative vectors. If one vector is situated in one direction, let's say 3 Newton, and the other 3 Newton is situated exactly in the opposite direction. So see, magnitude is still the same. Can you see both the magnitudes are still the same? But direction is exactly opposite. Okay, direction here is opposite. So you have opposite directions. So equal
Ma'am,
vectors,
but the arrow on the
exact,
F2 is in the same.
no, opposite, no? This is
So
pointing towards
on
right.
on top of it, on top of F2.
This,
Yeah.
this is the symbol for vector. This is a vector. It is not
What
showing
it
its
direction?
direction. Okay. It's not that if a vector is acting upward, so you will mark it like this. And if it is acting towards left, you'll mark it like this and this. No, symbol is this. In wherever the vector is acting, this is the symbol to show vectors. Like when you have something, you write the unit. Even if the unit is smaller or the unit is bigger, it doesn't affect your answer. If the unit is Newton, you will put Newton only wherever the force is acting. So like this is a symbol for it. Okay, so this is not representing the direction. This is representing the direction. Okay.
Okay, ma'am.
Then you have parallel vectors and anti-parallel vectors. These are also very important. Parallel vectors mean, parallel vectors mean, let's say F1 is equal to 4 Newton. F2 is equal to 8 Newton. Means vectors have the same direction. But the magnitude can be same, it cannot be same. Magnitude can be same or different. See, if magnitude is also same, it will become equal vectors. If the magnitude is same, 4, 4 or 8, 8, it will become equal vectors. What were there in equal vectors? Same direction, same value. So here also, if the two magnitudes are same, it will become equal vector. If magnitudes are different, it is a parallel vector. But see, magnitude can be same or different. So you can say all the equal vectors are definitely parallel. All the equal vectors are definitely parallel vectors. But all the parallel vectors might not be the equal vectors. What if their magnitudes are different? Then it will not be equal. So for parallel vector to be called as an equal vector, only it is possible when the magnitude is same. If magnitude is different, then you will not call them as parallel. So you can say all equal vectors are parallel, but all parallel vectors may not be equal. Because if this is the case, this is not equal. Then you have anti-parallel vectors. Anti-parallel vectors means, let's say F1 is 4 Newton, F2 is acting in the opposite direction, 8 Newton. So here opposite direction is fixed. Direction will be opposite in any case. But what about the magnitude? Magnitude can be same or different. Magnitude can be same or different. If it is same, it will become exactly like the negative vectors. If the magnitude is same, look, 3 Newton, 3 Newton, same here. If the magnitude is same. But if it is not, then it is anti-parallel. So all negative vectors, all these negative vectors are anti-parallel. They are in opposite direction. Anti-parallel means opposite direction. So all negative vectors are anti-parallel, but all anti-parallel may not be negative, because for being negative, magnitude should be same, and being the magnitude same every time is not possible. So we say all the negative vectors are anti-parallel because they are in opposite direction. And what about parallel vectors? Parallel vectors means vectors have to be in the same direction. Means angle between the two vectors is 0 degree. Anti-parallel means the angle between the two vectors is 180 degree. Tell me, is this whole part clear?
Ma'am, can you explain the angle part again?
Angle, see, if I have two vectors like this, okay, I overlap them. Is there any net angle I'm getting? No, if I just take this arrow and I put it on the top of it, so it will be overlapping. So if I want to calculate how much angle is there, so it will be 0. Now see, I'm increasing the angle. I'm taking it to opposite direction. Now can we say the angle is 180 degree? Yes. So one vector here, one vector here, angle is 180 degree. This is anti-parallel. This is 0 degree parallel. Okay.
Yeah, ma'am, got it.
All right, then I shall write it till here.
Done, mom. Mom, but when we are writing vectors, like when we write it, not type it, we have to write it with the arrow, right?
What, Aisha?
When we are writing it, we have to make the arrow and not bold it, right?
Yeah. Don't bold it. Just write the arrow. That will be sufficient. Yeah.
Done, mom. Done, mom. Done, ma'am.
Let's continue. Now, the topic that I'm starting with is unit vectors. Unit vectors are one big whole topic. Once completed, then we'll move on to the parallelogram law and all. Unit vectors, what are unit? Now, from the term unit, unit means unity. The term unit is derived from the term unity. That means one. So, unit vectors means those vectors whose magnitude is one. How? Like this. If force is 1 Newton, velocity is 1 meter per second, acceleration is 1 meter per second square, torque is 1 Newton per meter, 1 Newton meter. So, like this, if you have any vectors whose magnitude is 1, we call them as unit vectors. Very simple, unit vectors from the term unity. Now, a cap is used to represent a unit vector. Cap means like this. If there's a vector A, you will see this symbol. Often you will see I cap, J cap, K cap, these terms are used. So this is what we represent the unit vectors as. So this is the unit vector, how it is represented with with a cap on its head, unit vector. Like F cap, V cap. F cap is 1 Newton due east. V cap is 1 meter per second along x-axis like this. So this is how you write the unit vectors.
So
Now
unit
the
vector
formula, yeah,
direction dependent?
vectors are direction dependent. All the vectors, all the
No, but
vectors,
like unit vectors. We
unit
call them a
vectors
unit
also.
vector if it's equal to 1, irrespective of the direction.
No, no.
Oh,
Vectors are always associated with a direction. It's just that this force could have been 3 Newton due east, but it is 1 Newton only because it's a unit vector. Direction will always be specified. You cannot detach direction. If you are able to detach a direction, that means this is not a vector quantity. It's a scalar. Okay?
okay.
Now, see, how do you write the formula? Let me just tell you the basic formula, then we'll study more things. Let's say you have to create a unit vector. Take the vector as it is, divide the vector by its magnitude. Now, what is this? This is what? This is the unit vector A. Unit vector A. What is this? This is the vector A, not the unit one, the actual vector A. What is this? This is the magnitude of the vector A. This is the magnitude of the vector A. Okay, this is the magnitude of the vector A. This is A cap is A vector divided by its magnitude. So A cap we'll calculate using this formula. But how to calculate the magnitude, that I'll tell you later in this part only. Before that, you write down it till here, Aisha. Okay, then I'll tell you one more thing.
Okay. Done, ma'am. Done, ma'am.
See, Aisha, there are certain universal unit vectors that you have to remember and will be used throughout. So, how to solve the unit vectors, that I'll tell you. But what are these universal unit vectors? Understand them first. Basically, the unit vector that is chosen along x-axis. This is represented by the symbol I cap. Means I is letter with a cap on its top. It's the unit vector along x-axis. Means whenever you have, see, universal means something that is fixed, that is valid anywhere in the universe. This is what is meant by universal. Now, these three axes are always fixed: your x axis, your y axis, your z axis. These are always fixed. No matter what, your axis will never change. So, we call these as universal unit vectors. Means the vectors which are universally fixed. Once you study this here, now till your class 12th, you will be able to utilize them. That's why we use the term universal unit vectors. This means whatever is the unit vector along x-axis is called as the I cap. Now, if it is a positive x-axis, use plus I cap. If it's a negative x-axis, use minus I cap. Similarly, this letter J cap is used for the universal unit vector along the y-axis. Positive J cap above, negative J cap below. Means for positive y axis use plus J cap, negative y axis use minus J cap. Z axis is the outward axis, like this, a three-dimensional axis. So universal unit vector used along Z axis is K cap. So for positive Z axis, which is away out of the screen towards you like this is plus K cap. Towards me, this is minus K cap. Now, how do you use them? Suppose I want to tell you the force is acting towards the x-axis, positive x-axis. Let's say 2 Newton of force is acting along the positive x-axis. So I can just say 2I cap. I don't need to write all these things. I don't need to explain all these things. I can simply say 2I cap. Or if I find a vector, let's say acceleration is minus 18 K cap. So 18 is the magnitude, minus K cap will be its direction. So by just looking at the term minus 18 K cap, I will know that 18 acting along negative z axis. Minus K cap means negative z axis. So you can interpret things like this. If I am saying I have a velocity acting along the negative y axis whose magnitude is 73 meter per second. So I know 73 meter per second is acting along negative y-axis. So I can say 73 minus j cap minus 73 j cap. That will give me an idea. So this is what are universal unit vectors. Write them properly, Aisha. Draw this graph and all, write it in detail and properly write it because these are very helpful and we'll be using them. Then I'll tell you how we actually solve the unit vectors. Okay, please write it first.
Okay. Done now.
Okay, look, Aisha, now let us discuss how we write the magnitude and how we make the unit vector. First, understand what is the Cartesian form and what is this polar form. When we have vectors, vectors are written either in the polar form or the Cartesian form. Now, polar form means an angle is given between two vectors. If I say two velocities are acting at 30 degrees to each other, like this. Okay, when angle is given, then you use the polar form. If x, y, z axes are given to you, you use the Cartesian form. Okay, polar form when angle, Cartesian form when this. Right now, we are studying Cartesian form. Okay.
Ma'am, can you explain polar form again?
Polar form means between two vectors, angle will be given to you in the question. Like right now, till we studied whatever we have studied, was there any angle that these two vectors were acting at this angle? Angle didn't come till now. So we'll study that in the polar form. This was Cartesian form, means along x, y, z, coordinate geometry. That came, we just saw x, y, and z. So this is what we are studying. That is what is written Cartesian form. Now, when we write a vector, let's say example force is 3i cap plus 2j cap plus 4k cap. This means 3 units of force along the x-axis, 2 units of force along the y-axis, 4 units of force along the z-axis. All these are there is one single force whose different values are present. So component A1 is what I've written it in general form also. A is A1 I cap plus A2 J cap plus A3 K cap. So A1 is the component along x-axis, A2 is the component along y-axis, A3 is the component along z-axis. Now, how do you calculate the magnitude? Magnitude is calculated using, let's say I want to calculate the magnitude of the vector A. Under root of A1 square plus A2 square plus A3 square. This square. This is the formula. That's all. How? Let's take that example which I discussed, the force one. So example given is 3, 2, and 4. Look, the magnitude of force will be, tell me Aisha, what will be the magnitude of force?
3 square plus 2 square plus 4 square.
Very good. This will be 3 square plus 2 square plus 4 square, which you can solve later. I'm just putting it like this. That's how we calculate the magnitude. Okay, now we'll see how to make the unit vector. Write it down.
Done. Done, mom. Do I calculate that root thingy or no?
No, then let's see the rest of the questions. Then there you can see this says a vector is there. We have to calculate its unit vector. Calculate its unit vector. See, for the unit vector, you take the, for making the unit vector, you take the vector as it is and divide it by its magnitude. So for that, we require the magnitude at its first place. So Aisha, tell me, how will I write the magnitude of A?
Will it be 0 or 1
By 0?
for the I?
If it is 0, then there wouldn't have been any I. 0 into I cap would have been 0.
Oh, so 1.
So 1. Yes,
1 square.
1 square plus. For J cap, what do we write?
Minus 2 square?
Minus 2 square. Very good, because coefficient is completely with this negative sign. Plus, what's left?
Square.
Very good. So this will be under root of 1 plus 4 plus 9. See, the magnitude is coming root 14. So this is just the magnitude. देखो यहाँ पर vector is what? Vector as it is I cap minus 2j cap plus 3 cap है. Now when you divide it with its magnitude we have calculated root 14. It's actually you're dividing this term with this. I cap minus 2j cap plus
Mom,
3
वो
k
division
cap
होगा.
divided by root 14. So you can leave your answer like this also. Sometimes you can write your answer like this also. I by root 14 minus 2j cap by root 14 plus 3k cap by root 14. Now this depends who is your teacher or how does the answer is expected from you. Dekho, usually you can leave your answers like this also. That is also acceptable, okay? But this is also the same way of writing. So if you get a question, yeah, ऐसे लिखा होगा. So it doesn't mean that this is something new or a different concept is there. It's the same thing. You join the denominator, it's actually root 14 only. So that's how we write the unit vectors. Okay. This question you will tell me the answer to it. But first write this down properly, then I'll
Done, ma'am. Ma'am, for J and K, we take the values as -1.
For what?
For G and K, we take it as -1 while
M
calculating the
J
magnitude.
cap and K cap.
Yeah, -1.
Yeah, -1. You have to take
Okay.
the coefficient, entire coefficient. That is minus.
Okay. Done, ma'am.
Okay, let's match the answers. A vector is I cap minus J cap minus K cap. See, when we take out the magnitude, what's your magnitude coming?
√3.
-1 square plus -1 square, that is √3. Now, when you are making the unit vector, take the vector as it is divided by its magnitude. So this is I cap minus J cap minus K cap divided by √3. Or you can write this as I cap by √3 minus J cap by √3 minus K cap by √3. Okay?
Yeah.
You've written till here?
Yeah.
Let's come to the addition and subtraction in the Cartesian form. Look, you have a vector with its various coefficients, a1 I cap, a2 J cap, a3 K cap. B vector is there with its coefficient, b1 I cap, b2 J cap, b3 K cap. Just add all the like coefficients together. These will be added together, these will be subtracted together. Like if I have to write these, A vector plus B vector is equal to A1 plus B1 I cap, plus you have A2 plus B2 J cap.
Ma'am, does the I, J, and K cap have some value?
No, 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 no. Their magnitude is 1, but you just write it as it is to show its direction.
Oh.
They don't have a value. You just put it like I cap, J cap, K cap. It will just tell the direction. No, this component is situated along this direction, along this axis, whether it's positive, negative. Plus A3 plus B3 K cap. And if it's subtraction, you will just write the same thing. A minus B. Wherever we had plus sign, it will be minus A1 minus B1. I cap plus A2 minus B2 J cap plus A3 minus B3 K cap. That's how you have to add vectors, you have to subtract. Let's take an example and discuss. Let's say this is E vector plus F vector. I have to write E vector plus F vector. So here the coefficient of I cap is, and
3
here
plus
it
2.
is 2. Exactly. So 3 plus 2 I cap. Plus here we have 2
Plus 9 J cap.
plus 9 J cap. Very good. This is plus 9 J cap. Plus here this is minus 1.
1 plus 3 K cap.
Correct. Now, so we can write this as 5 I cap plus 11 J cap plus 2 K cap. So this is the resultant, that is E plus F. If I have the same thing, I want to write E vector minus F vector, means I'm going to subtract both of these. I can write 3 minus 2 I cap plus 2 minus 9 J cap plus minus 1 plus, no, subtracting. Minus 1 minus 3 K cap. This will be 3 minus 2 is 1. You write 1, you just write I cap. Both are the same. This will be minus 7 J cap minus 4 K cap. So what is this? E vector minus F. Tell me, addition and subtraction is clear to you?
Yeah, ma'am.
Okay then. Okay, Aisha, write it till here.
Okay, ma'am. Done, ma'am. Done, ma'am. Ma'am, what do you mean find the magnitude of the resultant vector C?
Add these two vectors A and B, and whatever vector you get now, see, then calculate its magnitude. Okay.
Okay, ma'am.
Okay, let's discuss this question, Aisha. Resultant C means we are adding both the vectors. So C will be 3 plus 0 I cap plus. Then you have 6. Then you have minus 4 j cap plus. This is minus 2 plus 3 j cap. So C resultant will be 3 I cap plus 6 minus 4, 2 j cap, 3 minus 2 plus 3, that is plus 1 k cap. Now we need to find out its magnitude. So magnitude is given by under root of 3 whole square plus 2 whole square plus 1 whole square. So this can be written directly as 9 plus 4 plus 1. Root 14 is the answer to this question. Is that clear?
Yeah, ma'am.
Please write it.
Done, ma'am. It's the same question as the above one, just that we have to subtract, right?
Yes, exactly. We just have to subtract it.
Okay.
Okay, let's discuss. This is the last question of your unit vector. H minus I, we have to get. The H, when you have H minus I, 2 minus of minus 3. This much of I cap plus minus 2 minus 4 J cap plus minus 1 minus 0 K cap. 2 plus 3, this is 5 I cap. This is minus 2 minus 4 minus 6 J cap. This is minus K cap. See, when we are calculating its magnitude, it will be under root of 5 square plus minus 6 square plus minus 1 square. So this is equal to 25 plus 36 plus 1. So that will be equal to, this is 11 and 61, 62, root 62. So this will be the answer. Is that clear?
Yeah, ma'am.
Please write it.